Hello everyone, my name is Anmol and I am your chemistry SME. Today we are solving FLT3 chemistry section. Okay, so let's start. So first of all, question number 56. With respect to the conformers of ethane, which of the following statement is true? Okay, bond angle remains the same but bond length changes. Bond angle changes but bond length remains same. Both bond angle and bond length change. Both bond angle and bond length remain same. Okay, so we know there are two main conformers of ethane. First one is staggered, which is the stable form, and another one is eclipse, which is the less stable form. Okay, so the bond angle, which is HCH and HCC, remain approximately at 109.5 degree as the tetrahedral geometry. Okay, and the bond length, which is carbon carbon and carbon hydrogen, also remain constant. Okay, constant because of the rotation does not affect the covalent bond themselves. Okay, so the correct answer is question number is option number 4. Both bond angle and bond length remain same. Okay, so now let's come to question number 47, which is compound X on reaction with O3, which is ozone, followed by ZnH2O, gives formaldehyde and 2-methyl propanol as product. The compound X is okay. So ozone lysis, we know ozone lysis is a very important reaction. Okay, so we are taking the compound X. First of all is CH3, CH, CH3, CH, double bond, CH2. Okay, so when ozonolysis reaction will take place, so this bond will break and double bond will be attached at this side. Double bond will attached at this side because of O3 and Z and H2. Okay, so this is CS3, CS3 on this side, CH, then single bond CH and double bond this side, and plus formaldehyde will also be formed. This is a normal ozonolysis reaction. Okay, so the correct option is option number 1. Now comes to question number 48. The UPSC name of the following compound is, this is the very easy question. Okay, so first of all we have to write the longest carbon chain. So 1 2 3 4 5 6. Now we have to decide the name by lowest set of locants. Okay, so there is, in third position we have alcohol group, in fifth position we have chlorine group, and in first position we have bromine group. Okay, so 1 bromo, 5 chloro, 4 methyl, hex ane, 3 on. Okay, 1 bromo because of alphabetical order we have to write. Okay, so correct option is option number 1. Now question number 49. Given below are two statements. Statement 1: in the Lucas test, primary, secondary, and tertiary alcohol are distinguished based on their reactivity with concentrated HCl and ZnCl2, which is known as Lucas reagent. Okay. Statement 2 is primary alcohol are the most reactive and immediate produce turbidity at room temperature upon reaction with Lucas reagent. Okay, so let's check. So we know first degree, second degree, and third degree alcohol are distinguished by the Lucas test on basis of the time taken for turbidity to appear. Yes, this is the correct statement. And we know 1 degree alcohol will give the turbidity in maximum time, which is around 30 minutes. 2 degree alcohol will give the turbidity in means 5 to 10 minutes. Okay, and the 3 degree alcohol will give the immediate turbidity. Okay, and the reactivity of alcohol is 3 degree, 2 degree, and 1 degree. 3 degree will take the less time, least time, and 1 degree take the maximum time. Okay, so option number 3 is our correct answer. Okay, yes, option number 3 is our correct answer. So now let's comes to question number 50. Which of the following sequence of reaction is suitable to synthesize chlorobenzene? Okay, we have to synthesize, we have to make chlorobenzene. Chlorobenzene means this. So there are four reaction, which is benzene, Cl2, and anhydrous FeCl3. Okay, so let's test with benzene and Cl2. Okay, so we have benzene, then we have Cl2 and anhydrous FeCl3. We know that Cl2 with anhydrous FeCl3 will produce uh, chlorobenzene with HCl. Okay, so this is the classic Friedel-Crafts chlorination reaction where benzene react with chlorine gas in presence of a Lewis acid catalyst like anhydrous FeCl3 to produce chlorobenzene, and this reaction proceed by electrophilic aromatic substitution. Okay, so option number 1 is our correct answer. Okay, now comes to question number 51. The Cajahal's methods for the estimation of nitrogen can be used to estimate the amount of nitrogen in which one of the following compounds. Okay, so for the question number 51, we know Cajal's method is not applicable to the compounds containing nitrogen having nitro and azo group. Okay, and the nitrogen present in the ring, which is pyridine, as nitrogen of these compounds does not change to ammonium sulfate under these conditions. Okay, so option number 3, which is aniline, is our correct answer. Okay, question number 52. Choose the correct statement. Okay, we have to choose one of the correct statement from the four options. Okay, first one is diamond and graphite have two-dimensional networks. Diamond is covalent and graphite is ionic. Diamond is sp3 hybridized and graphite is sp2 hybridized. Both diamond and graphite are used as dry lubricant. Okay, we know in diamond each carbon is bonded with four other carbon atoms. Okay, so hybridization of carbon is sp3. In graphite each carbon is bonded with three other carbon atoms, so hybridization is sp2. Okay, so option number 3, diamond sp3 hybridized and graphite sp2 hybridized, is our correct answer. Now question number 53. Given below are two statements. Okay, statement 1 is the acidic strength of mono-substituted nitrophenol is higher than phenol because of the electron withdrawing nitro group. Okay, statement 2 is orthonitrophenol, metanitrophenol, and paranitrophenol will have the same acidic strength as they have one nitro group attached to the phenolic ring. In the light of the above statement, choose the most appropriate. Okay, so we know statement 2, this statement 2 question is very important. This is asked several times, very repetitive question this is. Okay, remember the statement 2. Okay, so first of all, the order of acidic strength is, okay, so first of all we have to learn this order. This is very very important, very important order. Okay, so the order is, first of all, we have phenol, and in para position we have NO2 group, nitro group, and then phenol in ortho position we have NO2 group, then phenol in meta position we have NO2 group, and at last we have normal phenol. Okay, so orthonitrophenol has the highest acidic strength due to intramolecular hydrogen bonding which stabilize the phenoxide ion. Okay, then paranitrophenol has higher acidic strength than meta due to resonance effect which delocalize the negative charge on the phenoxide ion. Okay, so option number 3 is our correct answer. Now comes to question number 54. Given below are two statements. Statement 1 is primary aliphatic amines reacts with HNO2 to give unstable diazonium salt. Okay. Statement 2, primary aromatic amines react with HNO2 to form diazonium salt which are stable even above 300 Kelvin. Okay. So we know RNH2 is a primary aliphatic amines and it react with HNO2 to form RN2 minus, which is alkyl diazonium salt and which is unstable. Okay, and in the second statement it's asking for primary aromatic amines. So very simple example from primary aromatic amines is aniline. In benzene ring we are attaching NO2 group, in NH2 group. Okay, it reacts with HNO2 to form diazonium salt, alkyl diazonium ion, stable at low temperature which is 0 to 5 degrees Celsius. Okay, so the correct option will be option number 3, which is statement 1 is correct but statement 2 is incorrect. Now comes to question number 55. What is Y in the reaction? Okay, we have to find Y in the reaction. Okay, so first of all we are reacting RMgX with CO2 in dry ether. Then Y is formed. Then in Y we are reacting with H plus H2O, or you can say hydronium ion, then our acid group is forming. Okay. So in the given reaction, RMgX is the Grignard reagent and CO2 is the dry ice. Okay. So in the reaction is completing in two steps, which is attack of the Grignard reagent on CO2 and acidification of carboxylic salt. Okay, so first of all we are given with RMgX. It is reacting with CO2 to forming R C double bond O minus, then MgX group, and on hydronium ion it is giving ROOH group. Okay, so it is asking for Y, and the Y is R C double bond O minus MgX. Okay, Mg positive and X minus. Okay, Mg positive and X minus. Okay, so the correct answer will be option number 1. Now comes to question number 56. Which is the incorrect match for the energy distance function for the following interaction? Okay, so we are given with Debye force, ion induced dipole interaction, London force, and Kimson force. Okay, so the ion induced dipole interaction, which is r ki power minus 2 explanation, this is the incorrect one. Okay, so the correct explanation is ion induced dipole interaction follow the energy distance function as r to the power minus 4, not r raised to power minus 2. This is incorrect, and all other are correct. 1 2 1 3 and option number 4 are correct ones. Okay, so correct answer is option number 2. Now comes to question number 57. Identify the incorrect order of boiling point in the following pair. Okay, so we are given with the four option, which is boron, then OH whole thrice, boron, OCS3 whole thrice, NF3, N CS3 whole thrice, BF3, B CS3 whole thrice, C2H6 and C2F6. Okay, we have to identify the incorrect pair of boiling point. Okay, so the option number 1, which is BOH whole thrice, is not greater than, is you can say less than BOCS3 whole thrice. Okay, so this is incorrect because BOH whole thrice has a hydrogen bonding. It has an hydrogen bonding which increases its boiling point. Okay, so BOH whole thrice does not have hydrogen bonding, making it boiling point lower. Okay, so this has higher boiling point, higher BP, because of hydrogen bonding, because of hydrogen bonding, because of hydrogen bonding. So option number 1 is the correct answer. A gas which exists in three allotropic form, which is alpha, beta, and gamma. Okay, is, so the given option are SO2, SO3, CO2, and NH3, which is ammonia. Okay, so the correct answer is SO3. A gas which can exist in three allotropic form is alpha, beta, or gamma. SO2 exists only in two form, which is alpha, beta, and SO3 exists in three allotropic forms, which is alpha, beta, gamma. CO2 has one form in the gaseous state. NH3 has only one form, which is in gaseous state. Okay, so option number 2 is our correct answer, which is sulfur uh, sulfur trioxide. Now comes to question number 59. Okay, question number 59. A red colored mixed oxide, which is X, on treatment with concentrated HNO3 gives a compound Y. Okay, then Y with HCl produce a chloride compound Z. Okay, which can also be produced by treating X. Okay, by treating X with concentrated HCl. Okay, the compound X, Y, and Z will be. Okay, so first of all, P3 PB3O4 is a red colored mixed oxide. Okay, when we react it with concentrated HNO3, it form PbO2. Okay, PbO2. When we react PbO2 reacts with HCl to form PbCl2. Okay, then PbCl2 can also be formed by reacting Pb3O4 with concentrated HCl. Okay, So the correct answer for X is Pb3 whole 4, correct answer for Y will be PbO2, and correct answer for Z is PbCl2. So correct answer is option number 2. Okay, now comes to question number 60, which is an assertion reason question. Assertion is DNA is more stable than RNA in cellular condition. Okay, and reason is DNA lacks a 2 hydroxyl group, which makes it less prone to hydrolysis. Okay, so let's see. Assertion states that DNA is more stable than RNA in cellular condition, which is true. Yes, okay. And reason states that DNA lacks 2 hydroxyl group, which makes it less prone to hydrolysis. This is also true. This statement is also true, which provides a correct explanation for the assertion. Okay. The 2-hydroxyl group in RNA makes it more susceptible to hydrolysis, which can be led to degradation of the molecule. In contrast, DNA lacks this group, okay, making it more resistant to hydrolysis and therefore more stable. Okay, so correct answer is option number 1, which is both assertion and reason are correct, and reason is the correct explanation of assertion. Now comes to question number 61. A mixture of potassium chlorate, oxalic acid, and sulfuric acid is heated. During the reaction, which element undergoes maximum change in the oxidation number? Okay, so the reaction will be, so I am writing the reaction here, which is 2KClO3. Okay, then it will react with C2H2O4 plus H2SO4, which is sulfuric acid, and it will give the compound K2SO4, K2SO4 plus 2 times of KCl plus 2 times of carbon dioxide plus 2 molecules of water. Okay, so here the oxidation state of Cl is plus 5. Okay, then here oxidation state of sulfur is plus 6. Here oxidation state of sulfur is also plus 6. Here oxidation state of K will oxidation state will be minus 1. Okay, okay, so the maximum changes, chlorine changes from plus 5 to minus 1 here, because the oxidation state of chlorine is minus 1. Okay, so chlorine changes from plus 5 to minus 1, which is a significant change of minus 6 units. Okay, so the correct answer will be option number 3, which is chlorine. Okay, now comes to question number 62. Half-life period of a first order reaction is 1386 seconds. Okay, the specific rate constant of the reaction is, okay, we have to find the specific rate constant for the reaction. Okay, so we are given for the first order reaction, the half life period is t1 by 2 is related to a specific rate constant k, which can be defined by k1 by 2 is equals to 0.69, just a second, 0.693 divided by k, which is the rate constant. Okay, so k will be 0.693 divided by 693 divided by half life. Okay, so we can directly put, so after putting the value of t1 by 2, which is 1386, we are getting the answer 0.5 into 10 raised to the power of minus 3, which is second inverse. Okay, so the correct answer will be option number 2. Now comes to question number 63. Question number 63. The most durable metal, the most durable metal plating on iron to protect against corrosion is, okay. So, so in zinc plating, which is galvanizing, is actually a more common and effective method for protecting zinc against corrosion, especially in atmospheric condition. Okay. So zinc is more anodic than iron, meaning it will corrode in place of iron, providing a sacrificial layer of protection. This is why galvanizing process or zinc plating is widely used to protect steel structures such as bridges, buildings, and vehicles. Okay, so option number 4, zinc plating, is the correct answer. Now comes to question number 64. The standard EMF of a galvanic cell involving cell reaction with n equals to 2 is found to be 0.295 volt at 25 degrees Celsius. The equilibrium constant of the reaction would be, okay, so we have to find the equilibrium constant. Equilibrium constant K we have to find, okay, equilibrium constant K. Now, first of all, we know that delta G is equals to minus NFE, or we can say delta G is also equals to minus RT ln K. Okay, and we know at equilibrium the value of delta G is 0. Okay, so when the value of delta G is 0, E will be equals to E naught, okay, which is standard EMF. So rearranging the equation, we get ln K is equals to NF E naught divided by RT. So putting the value of n is equals to 2, E naught equals to given value, which is 0.295 volt. F we know the value of farads. Okay, then value of universal gas constant we know, and the temperature given is 25 degrees Celsius, which is 298 Kelvin. Okay, so we can easily find the value of ln K, and from ln K we can find the value of K, which is 1 into 10 raised to power of 10, approximately 1 into 10 raised to power of 10, means option number 4 is our correct answer. Now comes to question number 65. All form ideal gas except, okay, so sorry, all form ideal solution except ideal solution. Okay, so first is benzene plus C6H5CH3 benzene and toluene, and then ethane and C2H5I, then we have chlorobenzene and bromobenzene, then we have C2H5I and ethanol. Okay, so ideal solution are formed when the molecules of two components are similar in shape and size. Okay, and the second condition is the intermolecular forces between the two components are similar. Okay, in option number 1, benzene and toluene, similar molecule, can form the ideal solution. Okay, then ethane and ethyl chloride, different molecule but still form an ideal solution due to similar London dispersion forces. Okay, then we have chlorobenzene and bromobenzene, similar molecule, form an ideal solution. And then option number 4, which is ethyl iodide and ethanol, different molecule with different intermolecular forces, which is dipole dipole and hydrogen bonding in ethanol, do not form ideal solution. So option number 4 is our correct answer. Now comes to question number 66. The vapor pressure of a solvent decreased by 10 mm of mercury when a non-volatile solute was added to the solvent. The mole fraction of the solute in the solution is 0.2. What should be the mole fraction of the solvent if the decrease? Okay, so first of all, we can take x1 as the mole fraction of solute, which is given as 0.2. Okay, then from the Raoult's law we can say that P naught minus Ps divided by P naught will be equals to mole fraction, which is x1, which is x1. Now uh, now putting the value, we get 10 divided by P naught is equals to 0.2. Okay, so the value of P naught comes to be 50 mm. The value of P naught is 50 mm. Now again, when P naught minus Ps is equals to 20 mm, then P naught minus Ps divided by P naught is equals to mole fraction of solute. So it will be 20 divided by 50 is equals to 0.4. Okay, so the mole fraction of solute is comes out to be 0.4, and so the mole fraction of solvent will be 1 minus 0.4, which is 0.6. Okay, because we know that the mole fraction of solute plus mole fraction of solvent will be equals to 1. So for the solvent, mole fraction value is 0.6, which is 0.6, means option number 2 is our correct answer. Now comes to question number 67. Which of the following complex ion is accepted to absorb visible light? accepted to absorb visible light. Okay, so transition metal complex can absorb visible light due to presence of unpaired electron in the d orbital. This is known as DD transition. Okay, so in option number 1 we have titanium, two molecules of En, diene, and two molecules of ammonia. So the oxidation state of titanium has 4 plus, means no unpaired electrons, which is D0 configuration. So it will not absorb light. Then first of all we will find the oxidation state, then we'll find the number of unpaired electrons. So Cr we have plus 3, means 3 unpaired electron in D3 configuration, which can absorb uh, which can absorb light and undergo DD transition. So option number 2 is our correct answer. Similarly, in Zn2 plus, no unpaired electrons, means no light can be absorbed. Similarly, in scandium 3 plus, no unpaired electron, so no light will be absorbed. So for question number 67, correct option is option number 2. Which one of the following octahedral complex will not show geometrical isomerism? Okay, so the option are MA5B, MA2B4, MA3B3, and MA4P2. Okay, so we have to learn all these type of compounds, so we can directly answer in the exam. uh, we don't have to draw each and every structure, and then we have to find for these basic structure we have to learn, so we can directly answer and can save our time. Okay, so so uh, so the compound is Ma5B. It cannot show the geometrical isomerism because the complex has only one B ligand and five A ligand. So which can be only arranged in one way in the octahedral geometry. Yes, there is only one possible way, so it will not show any geometrical isomerism. So correct answer is option number 1. Now comes to question number 69. Which of the following organometallic compound is alpha and pi bonded? Okay, so we have these four compounds given. In the compound, the CO, which is carbon monoxide ligand, are both alpha and pi bonded to the cobalt metal center. Okay, pi bonding, the carbon atom of CO donates a pair of electron to the metal center through a sigma bonding. Okay, and pi bonding, the oxygen atom of CO donates a pair of electron to the metal center through pi bonding. Okay, this type of bonding is known as synergic bonding, where the donation of sigma donation strengthens the pi back bonding. Okay, the other option do not exhibit both sigma and pi bonding. Okay, so here we are talking about option number 4. Option 4 we are talking about. Option 4 means CO, then we have 5 molecules of CO, carbon monoxide, and 1 molecule of NH3. In all other option, uh, we can't see this back pi bonding. Okay, so the correct answer is option number 4. Okay. In option 1, the cyclopentadiene CP ligand are pi bonded to the iron center. Okay, and Fe CH3 whole thrice, the methyl ligand are sigma bonded to the iron center. In option number 3, the ethylene C2H4 ligand is pi bonded to the phosphorus center. So correct answer is option number 4. Now comes to question number 70. Aqueous solution of FeSO4 gives test of both Fe2 plus and sulfate 2 minus, but the addition of excess of KCN, the solution ceases to give the test of Fe2 plus. This is due to the formation of, okay, when KCN is added to aqueous solution of FeSO4, the Fe ion reacts with the Cn ion and it will form Fe2 plus 6Cn minus. It will form FeCN6 4 minus. Okay, this complex is very stable and does not dissociate to Fe2 plus ion, which is why the solution ceases to give a test for Fe2 plus after the addition of excess KCl. Okay, so the option number 3, which is the complex The complex ion FeCN6 4 minus is our correct answer. Now comes to question number 71. The alpha is the fraction of Hi dissociated at equilibrium in the reaction. 2Hi gas gives a hydrogen gas plus iodine gas. Starting with 2 moles of Hi, the total number of moles of reactant and product at equilibrium are. Okay, so the given reaction is 2Hi, which is giving hydrogen gas plus iodine gas. Okay, so initially there are 2 moles of Hi. Okay, at equilibrium, uh, alpha fraction of Hi dissociate, so the moles of Hi dissociate is 2 alpha. Okay, the number of moles of hydrogen and iodine formed is alpha, since 2 molecules of Hi is forming 1 molecules of H2 and I2. This is very common and simple. The total number of mole of reactant and product at equilibrium is 2 initial mole of Hi minus 2 alpha moles of Hi plus alpha moles of H2 form plus alpha moles of I2 form. Oh, okay. So we can write in equation way, which is 2 minus 2 alpha plus 2 alpha. Okay, so 2 alpha will be cancelled out by 2 alpha. So the answer will be only 2. So option number 2 will be our correct answer. Now comes to question number 72. Following two equilibria are simultaneously established in a container. Okay, which is PCl5 is giving PCl3 plus chlorine gas, and carbon monoxide plus Cl2 gas is giving COCl2 gas. Okay, if some Ni is introduced in the container forming NiCO whole 4 gas, then at new equilibrium what will happen? Okay, so for question number 72, when Ni is introduced, it reacts with CO to form NiCO whole 4 gas, which reduce. So when Ni solid is introduced, it react with carbon monoxide gas to form NiCO whole 4 gas, which reduce the CO concentration. Okay, since CO is a reactant in the equilibrium, so CO plus Cl2 is giving COCl2. Its decrease will shift a equilibrium to the left, increasing Cl2 concentration. Increasing the Cl2 concentration. Now PCl3 plus Cl2 are in equilibrium with PCl5 gas. With an increase in Cl2 concentration, the equilibrium will shift to the right, decreasing PCl3 concentration. Okay, so option number second, which is PCl3 concentration will decrease, is our correct answer. Now comes to question number 73. Which one of the following compound is metallic and ferromagnetic? Okay, so for question number 73, CrO2. Okay, CrO2, chromium 4 oxide, is a metallic oxide that exhibit ferromagnetic behavior, meaning it is capable of being magnetized and is attract to magnets. Okay, the other option are not metallic and ferromagnetic. MnO2, manganese 4 oxide, is an antiferromagnetic material. Titanium 4 oxide is a semiconductor and not ferromagnetic. Vanadium 4 oxide is a semiconductor and exhibit metal insulator transition but is not ferromagnetic. So option number 3 is our correct answer. Now for question number 74, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. What is the atomic number of the element which is just below and above the element in periodic table? Okay, so the atomic number of the given compound is 15, and the atomic number of the compound just below the periodic table is, which is 15 plus 18, we can directly calculate, which can be 33. Okay, so the correct answer is option number 1. Now question number 75. In the periodic table, from left to right in periodic table, the atomic volume. Okay, so we know while going from left to right, atomic radius decreases. Okay, atomic radius decreases means the atomic volume does indeed decrease from left to right across the period, but then the increase again due to the filling of p orbital and the resulting electron repulsion. Okay, so it means first it will decrease because the atomic radius decreases, then it will increases. So option number 4 is our correct answer. Now question number 76. Which one of the following is never true for cathode rays? Okay, cathode rays are streams of electron, not electromagnetic wave. They possess kinetic energy, produces heat, and can exert mechanical pressure, but they are not electromagnetic waves. Means they are electromagnetic wave is our correct answer, which is wrong. Now comes to question number 77. The number of spherical node in 3p orbital are. Okay, so we have direct formula to calculate the number of spherical node. In the 3p orbital has one spherical node. In general, the number of radial nodes for an orbital is equal to n minus l minus 1, where n is the principal quantum number and l is the azimuthal quantum number. Okay, now we can directly apply the formula n minus l minus 1, which is 3 minus 1 equals to 1. Mean option number 1, which is our correct answer. Now comes to question number 78. 40 gram of carbonate of an alkali metal or alkaline earth metal containing some inert impurities are made to react with excess HCl solution. The liberated CO2 occupied 12.315 liter at 1 atm and 300 Kelvin. So we have to identify which one is the correct option. Now, to calculate the volume of CO2 at STP condition, we can say volume as V1. So it is calculating direct formula we are using. V1 divided by 273 will be equals to 1 into we are just using the ideal gas equation. Okay, so 1 into 12.315 divided by 300. Okay, so it will give us the volume, which is 12.2 liter at STP, standard temperature and pressure. Okay, now 11.2 liter of CO2 at STP is equivalent to 0.5 mole of CO2. Okay, suppose lithium is the metal, so lithium carbonate plus HCl is giving LiCl plus water plus carbon dioxide. Means zero point 0.5 moles of lithium carbonate will give 0.5 into 73.89, that is 37 gram of lithium carbonate. Okay, so we can find the impurity by 40 minus 37, which is 3 grams. Means 36.5 into 1 divided by 0.73, which is 50, which is 50. Means the mass of impurity is 3 gram and the metal is lithium. Okay, so the metal is lithium. Means option number 2 is our correct answer. Now comes to question number 79. Reversible expansion of an ideal gas under isothermal and adiabatic condition are shown in the figure. This is very common and very easy question, you can say. This is very repetitive and important question. Repetitive and important question, which is asked several times in the exam. So we have the initial point A. From A to B we have isothermal process, and from A to C we have adiabatic process. Okay, so we have to calculate which of the following is not correct. Okay, so since A to C represent adiabatic reversible expansion, so work is done at the expense of internal energy. Yes, because at adiabatic process value of Q is 0, heat exchange is 0. Therefore, there is a decrease in internal energy, so temperature decreases. Means delta U is equals to 0. So delta U adiabatic will be negative. Yes, delta U of adiabatic will be negative because Q value is 0. It is an isothermal process, and hence Ta is equals to Tb. It is talking about the options. It is talking about the option. Okay, so we have to find which is not correct. Means option number 3 is correct. Okay, option number 2 is also correct. And work done for isothermal is greater than adiabatic. Yes, this is true. The work done by isothermal is greater than. We can directly calculate by area under the graph. from area under the graph, we can say B is above the C point, so the work will be greater for isothermal. Means incorrect answer is option number 1. Okay. Now comes to question number 80. If the enthalpy change for the transition of liquid water to steam is 30 kilojoule per mole at 27 degrees Celsius, the entropy change for the process would be, okay. So the value of delta S is calculated using the formula delta S is equals to delta H divided by T. Okay. So the value of delta H is 30 kilojoule divided by 300. Means 300, it will directly give 100 joule per mole. Okay, per mole per Kelvin. So option number 4 is our correct answer. Now comes to question number 81. Which of the following pair of a chemical reaction is certain to result in a spontaneous reaction? Okay, spontaneous reaction occur when the Gibbs free energy delta G is negative. This is achieved when the reaction is exothermic, means delta H is negative and the entropy delta S is increasing, means delta S is positive, means uh, exothermic and increasing disorder. Increasing disorder means entropy is increasing, means option number 1 is our correct answer. Now comes to question number 82. Which one of the following molecule has the maximum dipole moment? Okay, among CO2, CH4, uh, ammonia and NF3. The dipole moment is a measure of separation of charge with a molecule. NH3 has a significant dipole moment due to the difference in electronegativity between the nitrogen and hydrogen, as well as the pyramidal shape, because shape of NH3 is like this. Due to lone pair, it has the highest dipole moment, means option number 3 is our correct answer. Now comes to question number 83. Which of the following pair of ions are isoelectronic and isostructural? Means same electron and same structure. Okay. So option number 3, we can directly solve. We can directly calculate the number of electron and structure. This is very basic question of chemical bonding. Chemical bonding chapter. Okay. If you check option number 3, which is ClO3 minus and SO3 2 minus, they are isoelectronic, means same number of electrons, have the same number of electron, while isostructural ion have the same shape and structure. ClO3 minus and SO3 2 minus both have a trigonal pyramidal shape and same number of electron as well. Okay, means option number 3 is our correct answer. Now question number 84, we have matched the following. Okay, so in list compound form and reaction of carbonyl compound with. Okay, so cyanohydrin. Okay, for cyanohydrin. Okay, okay, when we can form the cyanohydrin? Okay, when we will react ketone group with HCN. When we will react ketone group with HCN. When we will react ketone group with HCN means A24. When we will react ketone group with HCN, then cyanohydrin can form. Okay, we are reaction of the carbonyl compound with. Okay, then we have to form. Uh, then we can form what we can form. Okay, let's take acetal. Okay, so acetal can be formed. B can be formed. Acetal structure is C, OR, OR, and R group on this side. This can be formed by using R, C double bond O, H, means it can be formed by aldehyde. Okay, so B can be formed by aldehyde. Okay, means B can be formed by aldehyde and ROH means alcohol, by using aldehyde and alcohol. So for acetal it can be option number 3. Now Schiff's base. Okay, Schiff's base can be formed by on reaction with ketone with RNH2 in presence of H plus ion. Okay, and option number 4, which is oxime, can be formed by NH2OH with H plus ion. Okay, so by matching all this we will get option number 4 as our correct answer. Now comes to question number 85. An aromatic molecule will. Okay. So aromatic molecule have the following characteristic. It has planar ring. Okay. It has 4n plus 2 pi electron rule, which is also known as Huckel rules. Means the aromatic molecule follow Huckel rule, which state that it must have 4n plus 2 pi electron in the resonance structure where n is an integer, and it have to be cyclic. Means aromatic molecules are cyclic, means closed cyclic. So option number 4, which means all of these are the necessary condition. Now comes to question number 86. Which of the following statement is correct regarding the nucleophilicity of the given species? Okay. Option number 1, the methyl ion anion, which is CS3 minus, is the strongest nucleophile because of its negative charge, which makes it highly reactive. Ammonia NH3 is also nucleophile but less effective than CS3 minus. And water H2 is the weakest nucleophile in the series. Mean option number 1 is our correct answer. Now comes to question number 87. Transition element in lower oxidation state act as Lewis acid because they form complexes. Transition element in lower oxidation state have vacant orbitals. Yes, they have vacant d orbital, which allow them to accept electron pair and form complexes, act as Lewis acid. Okay, means option number 1 is our correct answer. Now comes to question number 88. The standard electron potential of Cu2 plus to Cu is 0.34 volt, and that of Ag plus to Ag is 0.8 volt. What is the cell potential of the reaction? Okay, so we know the cell potential E cell can be calculated by E value of E value of cathode minus E value of anode, electrode potential of cathode minus electrode potential of anode. So uh, take okay, so the electron potential of cathode, which is Ag plus to Ag and Cu2 plus to Cu, means the value of Ag plus to Ag is 0.8, and for Cu2 plus to Cu is plus 0.34, means we have to subtract it and we will get the value as 0.46, means option number 1 is our correct answer. Now comes to question number 89. The molar heat capacity of a diatomic gas at constant volume is 20.8 joule per Kelvin per mole. What is the ratio of molar heat capacity at constant pressure and constant volume gamma for this gas? Okay, for diatomic gas, the molar heat capacity constant volume, which is Cv, is related to the molar heat capacity at constant pressure, which is Cp. And we know the reaction is Cp is equals to Cv plus R. Okay, the value of Cv is given and we know the value of universal gas constant R. Okay, so we can directly calculate the value of Cp. So the value of Cp is coming to be 29.114 joule per Kelvin per mole. Now we can calculate the value of gamma, which is Cp by Cv. We know the value of Cp, we know the value of Cv. We can directly calculate, and the answer comes out to be 1.40, which is option number 2. Now comes to the last question, which is question number 90. In the first order reaction, the concentration of reactant decreasing from 0.8 molal to 0.2 molal in 20 minutes. Okay, what is the rate constant of the reaction? We have to calculate the rate constant of the reaction. Okay, so for the first order reaction, the integrated law is ln A naught divided by AT, with it is equals to KT, where A naught is the initial concentration and AT is the concentration at time t, and K is the rate constant. Okay, the value of A naught is 0.8, the value of AT is at time t is 0.2, and the time is 20 minutes. So rearranging the equation, we get the value of K is ln A naught value is 0.8, A2 value is AT value is 0.2, and time is 20 minutes. We get ln2 divided by 20, and after solving this we get the value as 0.0 0.0693 means 0.0693 means option number 2 is our correct answer. Option number 2 is our correct answer. So we have discussed all the questions. So thank you so much everyone.